Hi there. This is a sort of brief update video on my plans for testing the SDRPlay RSPdx against the Elad FDM DUO. My original plan was to use my two what should be identical ALA 1530 magnetic loops, connect one antenna to each receiver, and then it's very simple to just mute one receiver, unmute the other. And that's kind of important. Switching between receivers is important, particularly on medium wave where conditions of propagation shift very quickly, and obviously with QSB, with fading in and out, it's quite easy to compare the same signal on two receivers. If you're not fast enough to avoid any QSB, you can skew the results. So switching between receivers is really important. However, there's a slight complication in that, having done some tests on long wave and concluded that the performance of the RSPdx and the Elad FDM DUO are so similar, any small kind of discrepancies in the performance of the loops is going to potentially skew my results. And what I did to confirm that was basically to start looking at the noise floor on these loops at various frequencies, from long wave through AM, medium wave, and then into HF, 90 meters, 75 meters, etc., 60 meters. And although most of the time the noise floor and the signal to noise is almost identical, it's not in every case. And so because the performance of these two receivers is so similar, I can't afford even small discrepancies in the performance of the two antennas I'm using to interfere with the quality of the signals that I'm receiving. So on that basis, I've made the decision to use one antenna, use one loop with an antenna switch, one of which is here. So I've basically wired up one of my switches, and on one side of the switch is the RSPdx, on the other is the Elad FDM DUO. And at least this way, I can be absolutely certain that I'm not going to introduce any other sort of variables affecting the signal strength, clarity, whatever it might be, by using more than one antenna. So this is one antenna, one set of coax, one jumper cable, one power supply, and then just flicking between the switch. Now, like I said, you have to be quick, particularly on AM, switching between receivers because of QSB. And that was kind of, like I said, the rationale for using two antennas. But because the performance is so close on these radios, I just can't afford to introduce any other sort of potential variables, as I said. So I'll have to basically record a signal and then quickly switch, mute and unmute the receivers, and so we'll get a good idea as to the performance of both of these radios, and how they are comparable to each other. So yeah, that's a bit of a shame, but and as I said, my loops are very similar in performance. They are identical, but it is frequency dependent, and they're not absolutely identical across all frequencies, and so this is unfortunately kind of necessary. I wish I didn't have to do it, but it sort of also kind of makes sense, I suppose. Without a bench full of test equipment, actually collecting empirical data isn't really possible, and you can't always trust the signal strength and signal to noise numbers on SDR software, because the algorithms that calculate that are different between pieces of software anyway, so they nearly always don't match up. So yeah, it makes sense to, as I said, to use one antenna, one set of receiving equipment, at least up to the point of the receiver, and then just switch between receivers and see what we get. So at the moment, like I said, on long wave, the performance is very close. There's nothing in it, which is why it's necessary to use one antenna, I think, and that'll give the most accurate results. So there you go. So I thought I'd just do that little update. My G5RV is still standing, flexing a bit in the wind, but still looking pretty good, and neighbours seem to be happy with the situation, so it's all good so far. Okay, well, I just thought I'd post that little update. Thanks for watching, and 7-3.